Hello students, welcome you to this session. We are studying sets, one of the very simple topic. We studied some set operations, the properties, right? De Morgan's laws and a lot of verifications and what is Venn diagram, right? And today we are going to do some verifications. Then after that I'm going to teach some of the very important applications using cardinality. You know what is cardinal number? Number of elements in a set, right? That is called cardinal number. Empty set, what is the cardinal number? 0, because there is no element in that, right? Cardinal number of singleton set, 1. Singleton set means only one element, right? Okay, we start few sums. Look at this question. Show that, see the last line. A minus B intersection C equal to A minus B union A minus C. This is one of the De Morgan law of set difference, right? On 3 sets. One more De Morgan law is there. Here they asked to show this one. So it is show that, so both LHS and RHS must be same. So if they are different, you would have made some mistake. You have to check it again, right? A minus B intersection C is A minus B. The intersection become union, right? Union A minus C. But main thing, here the 3 sets A, B, C are given in set builder form. You have to convert it into roster form. Once you change the roster form, it's a very simple thing. But anyhow, it's a 5-mark question. So listen very carefully. So first I'm going to write A. So what is A here? Set of all x. So you have to find x value. But what is x? 6n. X is equal to 6n. X is, I want to find A. A, what they given here, set of all x. And x is equal to 6 into n. So I must know the value of n. Then you multiply by 6, you will get x value. And that x values, you take it as what? A. So let us start from n. What is n here? N belongs to w. What is w? Whole number. Whole number starting with 0. Natural number starting with 1, right? Here whole number, so start with 0. 0, 1, 2, 3, etc. Till what? And one more condition, n is less than 6. It is not less than or equal to. Less than 6. Don't take 6 before 6. Before 6 means 5.99, something like that. But here whole number, right? So before 6, which is the whole number? 5. Okay. So you start with 0, end with 5. 0, 1, 2, 3, 4, 5. So n values, whole number 0, 1, 2, 3, 4, 5. Because less than 6. If it is less than or equal to 6, you write up to 6. Now A you can write A equal to set of all x such that x equal to 6n. So multiply n values, you got it, no? You multiply every term by what? 6. So first 6 into 0, 0. 6 into 1, 6. 6 into 2, 12. 6 3s are 18. 6 4s are 24. 6 5s are 30. Only thing you need multiplication table, right? So this is A. Now let us see what is B. B equal to set of all x such that x equal to 2n. Now multiply by 2. But what is n here? In the second case, when you find B, n equal to 2n. X is equal to 2n. But what is n here? It is a natural number. But from where? Not from 1. 2 less than n less than or equal to 9. In between 2 and 9, 2 is not included, but 9 is included. So you start with 3. N equal to 3, 4, 5, 6, 7, 8, 9. The formula what they given? X equal to 2n. X equal to 2n. So multiply by 2 and say, multiply by 2, 3 2s are 6, 4 2s are 8, 5 2s are 10, 6 2s are 12, 7 2s 14, 16, 18, right? 9 2s are 18. That is B. Now we see C also. C equal to set of all x such that x equal to 3n. Multiply by 3. Multiply by 3. 3n. So see what is n here? N belongs to n. N belongs to n means n is a natural number. So 1, 2, 3, etc. But condition 4 less than or equal to n less than 10. So from 4 to 10, 4 is included, 10 is not included. Hope you understood the reason for that. So 4 to 10, but not 10. So before 10, 9, right? So 4, 5, 6, 7, 8, 9. This is n value, but x equal to 3n. X equal to 3n. So multiply by 3, 4 3s are 12, 5 3s are 15, 6 3s are 18, 21, 24, 9 3s are 27. All that A, B, C. Given in set builder form, we change to roster form. Now it is very simple to find LHS. To find LHS, first what do you need? B intersection C. First you find B intersection C. In elements which are common for B and C. See what is common here? 12 is common. 14, then 18 is common, right? So 12 and 18. B intersection C is 12, 18. So B intersection C. Next we need A minus B intersection C. A minus B intersection C. What's the meaning? Elements in A but not in B intersection C. You take the elements from A which are not in B intersection C. Don't take 12 and 18. Don't take this 12 and 18. All the remaining elements in A. What are the elements? 0, 6, 24, 30, right? 0, 6, 24, 30. So hope you understood. This is the answer for LHS. Take it as equation number 1. Now you find RHS. To find RHS, first what do you need? You need A minus B, then A minus C. Take their union. So let us find A minus B, then A minus C, then take their union. A minus B, union A minus C. Okay, let us do one by one. First A minus B. What's the meaning of A minus B? In A but not in B. Can you say elements which are in A but not in B? 0. It is in A but not in B. 6 you can't take, 12 you can't take, 18 you cannot take, 24, 30, right? In A but not in B. Now A minus C. In A but not in C. In A but not in C. You can take 0, 6, 12 you can't take, 18 you cannot take, 24 you can't take, 30, right? Now you find the union of these two. Write every element without repetition. So 0, 6, 24, 30, right? Every element you write one time. This is 2. Check 1 and 2. Are they same? 0, 6, 24, 30 same, right? So you can say from 1 and 2, A minus B intersection C equal to A minus B union A minus C. Okay, so like this you have to do this. So now, so these type questions are very simple. So look at this question number 7. It is very easy, right? What they asked to verify, show that A minus B union C is A minus B intersection A minus C. It's a very simple one because already A, B, C given in which form? Roster form. So I don't want to waste time. You can do it. Okay, complete that sum. Now we see the next question. Another very important question. See A, B, C, 3 sets. C is good, right? It is given in roster form. But A and B given in set builder form, you have to change it. Okay, so I'll explain that too. A equal to set of all Y. But what is Y? A plus 1 by 2. Y equal to A plus 1 by 2. But so, if you want to find Y, you must know A. What is A here? A belongs to W starting from 0, whole number. But A less than or equal to 5, only up to 5. 0, 1, 2, 3, 4, 5. So these values you substitute one by one. First time you put 0. For A, if you give 0, 0 plus 1. If you want, you can write and see. 0 plus 1 is 1 only. So 1 by 2. Then you put 1. When you give 1, for A you are giving 1. So see 1 plus 1, 2. 2 by 2. You can cancel it, no? 2 by 2. 2 to cancel, your answer is 1. Then you give 2. When you give 2, 2 plus 1, 3 by 2. So 3 by 2. You can't simplify, leave it. If you can cancel, you cancel it. Now you give 3. 3 plus 1, 4. 4 by 2. 4 by 2. You can cancel it, no? 4 by 2, cancel, you'll get 2. Then you give 4. 4 plus 1, 5 by 2. You can't simplify. Then you give 5. 5 plus 1, 6. 6 by 2. Can you simplify? Yes. You will get what? 3. Like that, if you want, you can write and see that you are not making mistakes. So this is A. Next, same method, I want B. B equal to set of all y, and how they define y? Y equal to 2n minus 1 by 2. So again you need what? Now it is in terms of n. I need the value of n. So what is n here? N is a whole number starting from 0. N is less than 5. So all the whole numbers less than 5. It is not less than or equal to less than 5. So up to 4. 0 to 4. 0, 1, 2, 3, 4. Give the values one by one. First you put 0, 2 into 0, 0, right? So 0 minus 1, so minus 1 by 2. Next you put 1. When you give 1, 2 into 1, 2. 2 minus 1, 1. If you want, you write. For n, you are giving 1. So 2 is simple calculation only, no? 2 into 1 is 2. Then 2 minus 1, 1. So 1 by 2. Now you give 2. 2 into 2, 4. 4 minus 1, 3. So 3 by 2. Next you give 3. 2 into 3, 6. 6 minus 1, 5. So 5 by 2. Denominator is 2 only. Then last you give 4. Try to find out what answer you get. You are giving 4 and see what's the answer you are getting. You substitute 4 for n. 2 into 4. What is 2 into 4? 8 minus 1. 8 minus 1 is 7 by 2, right? 7 by 2. That's all A and B. C already they given in the correct form, right? It is given in roster form. C equal to minus 1 by 2, 1, 3 by 2, 2. Then the remaining calculation, you know, first you find B union C, then A minus B union C, take it as 1. For right side, first you find A minus B, then A minus C, take the intersection, take the common elements, take that answer, you take it as 2. So check whether they are same. Okay, you can complete that. See this question. Here, universal set given, A, B, 2. So everything given in roster form, so easily you can do. Only thing what you need, verify De Morgan's laws. So you must know what are De Morgan's laws, which De Morgan's law they expect here. Verify De Morgan's laws for complementation. Read the question very carefully. There are 2 laws. De Morgan law for complementation, De Morgan laws for set difference. For set difference, they give 3 sets, A, B, C, but here only 2, right? Universal set will be given. Here also 2 De Morgan laws, right? A union B, the whole dash is A dash intersection B dash. Another one, A intersection B, the whole dash is A dash union B dash. Which one you have to prove here? Read it. Verify De Morgan laws given in plural form. So you have to verify both. Sometimes they specify verify one De Morgan law, right? Write both the laws, verify any one. Like that if they ask, okay. But here verify De Morgan laws. So both the laws you have to verify. So what are the De Morgan laws? The first one is A union B the whole dash. A union B the whole dash is A dash. The union become intersection B dash. And the second one is A intersection B the whole dash is A dash union B dash. Both the laws you have to verify. It's again a 5-mark question. I am going to verify the first one. Okay. So same way you can try the second one. Okay. So please listen for the first one. First, what do you need? A union B. We want A union B the whole dash. So first find A union B. Write every element A, B together. 4, 7, 8, 11, 12, 15. This is A union B. We want A union B the whole dash. Meaning elements which are not in A union B but in universal set. See, elements which are not here but here in the universal set. Can you find out the elements? 7, 4, 7, 8 there also. Then 10 you can write. It is not in A union B but in universal set. 11 you can't take, 12 you can't take, 15 you can't take, then 16. This is A union B the whole dash. Take it as equation number 1. Next, for right side, we want A dash, B dash, then their intersection, right? So first you find A dash. First you find A dash. So what's the meaning of A dash? Elements which are not in A, right? Elements which are not in A. So A dash is equal to, can you say the elements which are not in A? These are the elements in A. 7, 8, 11, 12. 7, 8, 11, 12. 7, 8, 11, 12. This is the easy way, but don't strike out in the question paper. Okay, so write the remaining elements. 4, 10, 15, 16. 4, 10, 15, 16. By seeing that you can say, right, which are not in A. So 4, 7, 8 you cannot take. 10 you can take. 11, 12 you cannot take, 15, 16. Okay, so this is A dash. Next we want B dash. What's the meaning of B dash? Elements which are not in B. Elements which are not in B. 4, 8, 12, 15. 4, 8, 12, 15. Leave that elements. Write the remaining. What are the remaining elements? 7, 10, 11, 16. 7, 10, 11, 16. 7, 10, 11, 16. So this is what? B dash. Now you take their intersection. A dash intersection B dash. What is intersection? Take the common elements. What are the common elements here? 10 and 16. Take it as equation number 2. See, 1 and 2, are they same? Yes. So from 1 and 2, A union B the whole dash equal to A dash intersection B dash is verified. Okay, now same way you can verify the second one. That also you must do. A intersection B the whole dash is A intersection B the whole dash is A dash union B dash. Okay, so this I'm leaving it to you. So how can you find this? First you find LHS. For that you find A intersection B, then A intersection B the whole dash. Right side A dash union B dash. Already here we did know A dash B dash. Take their union, then you will get the answer. Okay, so that you can complete. Then Venn diagrams already you know. If there are two Venn diagrams, how we draw? 2 means we draw like this. Okay, disjoint means we draw separately. 3 means we draw one more like this. But outside you draw universal set, right? So now I'm going to teach some applications. Using Venn diagram also we have a lot of applications that we'll teach in the next class. But today using cardinal number. Already I said when there is a union, right? When there is union, what do you have to do? When there is or we use union. And means we have to use what? Intersection. Okay, or we use union and we use intersection. And the portions how to shade in the in the Venn diagram. Suppose there are two sets A and B. A union B, no. A union B means the full portion, right? A union B is the full portion. Then what is this portion alone? A intersection B, common portion, right? A intersection B. This is A intersection B. Can you tell me what is this portion alone? What is that portion? What I shaded here. Can you tell me what is this portion? It is in A but not in B, right? In A but not in B. So this is A minus B. So this portion is what? A difference B. A minus B. In A but not in B. Same way, can you say what is this portion? That is in B but not in A, right? In B but not in A. B minus A. And this is A intersection B, right? So this is the main thing you need. So you here also we are going to apply some cardinal property here. So A means, N of A means two things you have to add, this and this, right? N of A minus B plus N of A intersection B. If you add these two, you will get A. Same way B means you have to add these two, right? These two if you add, you will get B. Okay, now let us see some of the applications. Okay, so this is a Venn diagram. Two sets A and B. Can you say what is this portion? That is A intersection B, right? So that portion is A intersection B. Can you say what is this portion? In A but not in B. So this is A difference B. Then what about this portion? B minus A, right? Now please listen here. How can you write N of A minus B? N of A minus B means this portion, right? How can you take this portion? It is in which one? It is in A, right? From A, remove this. From A, remove that portion. That is A intersection B. You will get what? A minus B. So from A, you have to. So N of A minus, you remove that middle portion. That is N of A intersection B. Same way, please listen, N of B minus A, this portion. I want only that portion. So that is in which set? B. So from B, you have to remove something. Which one? N of B minus, from the total B, remove this portion. What is that? A intersection B. So minus N of A intersection B, you will get B minus A. Okay, so this is important thing. No need to mug up anything. Just to draw a diagram, you must know the position. The middle one, you know, A intersection B. But in A, the first portion, that is A minus B. In B, the second one is what? B minus A. Then some of the very important results. The first one is called addition theorem. Just go through this. N of A union B, that's the most important one. N of A union B. Union, when you use, whenever there is R, we use union. Intersection is for what? And. In the next classes, we need this. So N of A union B is N of A plus N of B minus N of A intersection B. This is a relation connecting all the four. Which four? N of A, N of B, N of A union B, N of A intersection B. N of A union B is equal to, what's the formula? N of A plus N of B minus N of A intersection B. Okay, that is addition theorem, very important thing. Here they can frame questions in any form. They give 3, they'll ask you to find the fourth. They can give any 3. Sometimes they give N of A union B, N of A intersection. They'll ask you to find N of B. Okay, so like that. So no need to mug up different formula. This one formula you study, substitute the values given, from that you can find the unknown. Okay. Next one already I explained, N of A minus B. Using Venn diagram, you can understand very easily. This is A, this is B. N of A minus B, this is A minus B. If I want this portion from A, you remove this portion, that is A intersection B. So N of A minus N of A intersection B. Same way N of B minus, that's the other end, right? If I want this portion from B, you remove A intersection B. Another thing, very important thing, listen. N of A plus N of A dash, it is N of U. N of A plus N of A dash. N of A means elements in A and elements not in A. Totally, it is N of U, right? Listen, so A is this one, right? A means only this portion. A dash, it's outside portion, right? A dash is outside portion. Together, if you take, you will get what? The entire universal set. N of A plus N of A dash is N of U. Not only A, any set. N of B plus N of B dash is universal set. C means both C. N of C plus N of C dash. Don't take N of A plus N of C dash. It is wrong. When you take A, A dash. When you take B, B dash. Okay, N of A plus N of A dash is N of U. Here also they can frame questions. Sometimes they will give N of A dash and N of U. They'll ask you to find N of A. How can you find N of A? N of U minus N of A dash. Suppose if you want N of A dash, this is given, N of A is given, I want N of A dash. How can you write the formula? N of A dash equal to, already right side N of U is there. Take this N of A to that side, it become minus N of A. Okay, so this is very important thing. And in the first one, I want to teach you one more important result. Please listen, in the first one, that is I said addition theorem, right? N of A union B is equal to N of A plus N of B minus N of A intersection B. Suppose A and B are disjoint. What's the meaning of disjoint? Nothing is common, right? They are like this. So what is A intersection B? A intersection B is empty set. A intersection B become empty set. Then N of empty set, number of elements in an empty set is 0. So the last term becomes 0. So that won't be there. Your answer is N of A union B is equal to only N of A plus N of B. When there is a condition, not always. N of A union B equal to N of A plus N of B only when the two sets are what? Disjoint. Nothing is common. Otherwise, N of A union B is N of A plus N of B minus N of A intersection B. Okay, hope you understood all these things. So N of A intersection B, everything you can find from. This is the most important one. N of A plus N of A dash is what? N of U. If A and B are disjoint, N of A union B is only N of A plus N of B. You know the reason, last term become 0. Two sets we studied. N of A union B is N of A plus N of B minus N of A intersection B. If there are 3 sets, listen, one lengthy formula. If for a 3 finite sets ABC, for any 3 finite set ABC, N of A union B union C. One lengthy formula, looks like a train, right? So easily you can remember. First you take 1 at a time, then you take 2 at a time, then you take 3 at a time. Only 3 sets are there, A, B, C. 1 at a time means N of A, N of B, N of C. 2 at a time, AB, BC, AC. 2 at a time, what do you take? AB, BC, AC. 3 at a time, A, B, C. So A intersection B intersection C. First take one at a time. N of A plus N of B plus N of C. One at a time, everything positive. Two at a time, everything negative. A intersection B, B intersection C, A intersection C. N of, right? All the three negative. One at a time positive, now two at a time negative. So minus N of A intersection B, minus N of B intersection C, minus N of A intersection C. Then take all the three. First one at a time positive, two at a time negative, three at a time again positive. N of A intersection B intersection C. Everywhere intersection only. So look at the formula. N of A union B union C. N of A plus N of B plus N of C. Minus N of A intersection B minus N of B intersection C minus N of A intersection C. Then plus N of A intersection B intersection C. Okay, they'll ask you to verify these. So these are very, very important. Today I am going to teach few sums using this only. Okay, now we will go to the next exercise. Okay, listen, the first question. N of A is 25, N of A 25, N of B 40, N of A union B 50. There is a relation, I said, no? So we use that relation. We have, that is the most important addition theorem. We have N of A union B is equal to N of A plus N of B minus N of A intersection B. So here is substitute the values what you know. N of A union B, they given us what, 50. N of A 25, N of B 40, minus N of A intersection B, we don't know, they asked us to find. So 50 is equal to 65 minus N of A intersection B. Bring that negative term to the left side. So N of A intersection B is equal to 65 minus 50, you are getting 15. This is the answer for first part. N of A intersection B, got it. One more they asked. What they asked next? N of U. I said there is a formula for N of U, no? N of A plus N of A dash. Or N of B plus N of B dash. Here, which one you know? N of B, A we cannot use because we don't know N of A dash, right? But N of B dash given, N of B also given. So using that too, you can find N of U, right? So N of U equal to N of B plus N of B dash. So what is N of B here? 40. N of B dash is 25. So the answer is what? 65. So write the answers together. The last you say answer. Two things they asked to find. One is N of A intersection B. It is 15. And second one is N of universal set. It is what? 65. One more question of the same type so you can understand better. Look here. N of A given, N of A union B, N of A intersection B. So immediately you can find N of B. There is a relation connecting all the four. So we start from that addition theorem. We have N of A union B. Only two sets, no? Easy. What's the formula? Only three terms. N of A plus N of B minus N of A intersection B. Minus N of A intersection B. Substitute the known values. N of A union B 500. N of A 300. Plus N of B we don't know. Minus N of A intersection B 50. So 500 equal to 300 minus 50. It is 250 plus N of B. So we want N of B. Keep it here. Already left side 500. Take that 250 here minus 250. Right? So you are getting 500 minus 250 is what? 250 equal to N of B. So N of B is 250. One part. Second one, N of universal set. Again, like previous question, N of universal set. N of U equal to, here also N of B plus N of B dash. Because N of B, you got it now, 250 plus N of B dash, that is given in the question, right? What is that? 350. So that is substitute 350. So what you are getting? You are getting 600. So only just that two formula, you have to remember you can do that. Now look at the next question. This is to verify the addition theorem. So you find LHS and RHS. Check whether the answers are same. But only thing here, universal set is given in what? Set builder form. Other A and B given roster form only. U equal to set of all x. X is a natural number less than or equal to 10. Up to 10 you can take. Natural number starting with 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A equal to 2, 3, 4, 8, 10. B equal to 1, 2, 5, 8, 10. So we want to verify this. So for that, what are the things you need? You see, n of a, just count and write. Okay, so from the first, you can now itself you can say n of a equal to count the elements 1, 2, 3, 4, 5 elements. From the second, you can find n of b. How many elements are there? There also you have 5 elements, right? Now, so n of a, n of b. You want n of a union b, n of a intersection b, right? So you find a union b and a intersection b. A union b, find the union here, write every element 1, 2, 3, 4, 5. Then 8, 10. So you can say n of a union b is, count the elements here, totally 7 elements, right? Now we find a intersection b, elements which are common for a and b. Any common element? Yes, 2 is common. 3, 4 not common, 8, 10, right? So from here you can say n of a intersection b is equal to 3. Only 3 elements are there. Then what do you have to verify? You find both LHS and RHS separately. LHS is n of a union b. LHS is n of a union b. It is 7. RHS you write, RHS is n of a plus n of b minus n of a intersection b. Substitute the elements numbers, n of a 5 plus n of b also 5 minus n of a intersection b is 3. So 5 plus 5, it is 10 minus 3, so that is also 7 only. So LHS equal to RHS. That is, you write the result. N of A union B, N of A union B is equal to N of A plus N of B minus N of A intersection B is verified. Because it's a result, it must be true. If you get different answers, you have to check it, okay? This is the verification for 2 sets. It's a 2-mark question, but sometimes they'll ask you to verify in 3 sets. One result we studied, no? So that type also I'll give you a question. Look at this question. Verify n of a plus n of b plus n of c. N of a union b union c equal to n of a plus n of b plus n of c minus n of a intersection b minus n of b intersection c minus n of a intersection c plus n of a intersection b intersection c. For the following set, 2 sets given here, I am taking only 1, okay? Even if it is given in set builder form, you know how to change it, okay? So 3 sets given here, but lot of things you need, right? N of A, N of B, N of C, directly you know. Then what are the other things we need? A intersection B, B intersection C, A intersection C, then A intersection B intersection C, then A union B union C. So let us find A intersection B, right? Common for A and B. See what is common here? 3, 5, right? B intersection C, common for B and C, 5, 6, right? 5, 6. Common for A and C, A intersection C, first and last, 1, 5, right? Now another 2 more we need. A intersection, B intersection C. Is anything is common for all the 3? It is 5 is common for all the 3. Then finally A union, B union, C, right? Every element in all the 3 sets, right? 1, 2, 3 is there. 4 is not there. 5, 6, 7, right? So now all the sets we got it. Now we want the cardinal numbers, right? N of A. How many elements are in A? 3. N of B? 4. N of C? Also 4. Now N of A intersection B, how many elements are in A intersection B? 2. N of B intersection C, 2. N of A intersection C is also 2. Now the last 2, N of A intersection B intersection C is 1. N of A union B union C is 1, 2, 3, 4, 5, 6, right? Okay, everything got it. Now we find LHS and RHS. LHS, okay, very simple thing, right? So we write LHS, that is n of A union B union C. What is that? It is 6. Now you find RHS, right? Now we find RHS, that is n of A plus n of B plus n of C, taking one at a time, everything positive. Now we take two at a time, everything negative, right? Minus n of A intersection B, minus n of B intersection C, minus n of A intersection C. Now plus all the three at a time, A intersection B intersection C. Substitute and you check whether you are getting exactly 6. N of A 3 plus n of B 4, n of C 4, minus n of A intersection B 2, minus B intersection C 2, minus A intersection C also 2, plus A intersection B intersection C is 1, right? So now you check it. Positive value is 4 plus 4, 3 plus 1 also 4, it is 12. Minus 2, minus 2, minus 2, it is minus 6. 12 minus 6 is also 6. Take it as 2. Both answers are same, right? So you can say from 1 and 2. From 1 and 2, n of A union B union C equal to, write that result and you say is verified. What's the result? Again and again you say, write, practice. Okay. So n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C is verified. So like that, one more subdivision, the first subdivision left out, that you can do that. So hope you understood all these things. We'll continue in the next class.